Okay, let's unpack this. Have you ever gazed up at the night sky, or maybe even just looked closely at something like a snowflake, and felt that sort of quiet wonder about the patterns, the symmetries, the sheer order you see in the universe? It often feels like there's maybe a hidden melody playing through it all, you know?
Right. Some kind of deep organization.
Exactly. An organization beneath what might seem like just cosmic chaos. What if the very fabric of reality isn't just random chance or, I don't know, thermodynamic collapse, but something profoundly, beautifully organized?
Yeah.
Something that, well, literally sings itself into existence.
Well, this deep dive is into a truly fascinating paper that suggests exactly that. It's titled The Harmonic Emergence of Matter, a Unified Coherence Theory.
Huh?
And it posits a revolutionary, genuinely unifying framework for how everything, everywhere comes into being. It's a very fresh perspective. It challenges a lot of traditional physics with a foundational axiom that honestly offers a pretty elegant solution to some of the universe's deepest, most persistent questions. It's definitely been making us think differently about, well, everything, from subatomic particles right up to the largest galactic structures.
Wow. Okay, so our mission today is to really take you on a journey through this theory. We want to break down its core ideas, show you how it applies or how it claims to apply across all scales of existence,
Right.
and hopefully reveal some truly aha moments about the nature of reality itself. We're going to dive into concepts like coherence, harmonic reduction, and explore this really astonishing possibility that the universe isn't just expanding, but it's actively composing its own grand, ever-unfolding symphony.
It's a great way to put it.
So let's begin with the absolute foundational idea of this unified coherence theory, what it calls coherence physics. Imagine, if you will, a state of perfect undisturbed order, like a universal canvas maybe, an ultimate field of total symmetry and pure potential existing prior to any differentiation or structure appearing.
Right, before anything we recognize as stuff exists.
Exactly. This theory calls that the coherence field. And crucially, it's not seen as an emergent property that just pops up from interactions.
No, that's key. It's fundamental.
Right, it's fundamental. The pristine source from which everything else in our reality emerges. It's like the highest state of organization imaginable.
And what's truly fascinating here is what happens next, according to the theory. When this fundamental coherence reduces, and maybe that happens through an interaction or an observation, or even just, the imposition of certain boundary conditions.
Like symmetry breaking in standard physics.
Sort of analogous to that, yes. When it reduces, it doesn't just fall apart into chaos or disarray. That's the critical point.
Okay.
Instead, this process, which they call coherence reduction, transforms that high-order coherent state in an incredibly organized and structured way. Think of it less like an explosion and more like a single complex musical note that resolves itself into distinct harmonious tones.
Oh.
Each step of this reduction isn't random. It's a quantized, highly structured resolution, and it leads precisely to the stable phenomena we observe throughout the universe.
So it's very specific, lawful transformation, not just collapsing into disorder.
Exactly. Not a descent into randomness at all.
That's a powerful distinction. So instead of picturing, say, random explosion of particles from some primordial soup, or just everything thermodynamically decaying into randomness.
Right. The usual picture?
It's more like an immense, incredibly precise cosmic tuning process. Like I said, with music, as you tighten a string on a guitar, you don't just get noise. You get specific, predictable, stable notes. Each of those notes is a permitted, stable state.
That's the analogy.
So this theory suggests the universe operates similarly. It's not about chaos. It's about a deeply resonant, precise, and ordered unveiling of reality. Everything that comes into being is like a specific note or chord in a larger composition.
And that brings us directly to the very first, and you could argue the most profound axiom of this unified coherence theory. It's called the Coherence Harmonic Reduction Principle, or CHRP for short.
CHRP, okay.
Axiom CHRP1 formally states, all reductions of coherence resolve through discrete resonance harmonics, forming the structured basis for quantized physical systems.
Okay, let's break that down. Discrete resonance harmonics.
Right. Think of harmonics on a string. Again, only specific wavelengths fit, creating specific notes or overtones. This axiom says that when the fundamental coherence reduces, it has to do so by forming these specific allowed harmonic states.
And those form the basis for quantized systems. like electrons only having specific energy levels.
Precisely. This is the generative rule, the fundamental grammar by which the theory claims the universe self-structures itself at every conceivable scale. It means coherence reduction isn't arbitrary. It always resolves through these discrete, lawful resonance harmonics.
Here's where it gets really interesting for me, because these harmonics, they're not just abstract ideas or, mathematical constructs in this view.
Not at all. The paper details how they manifest as the very stable forms we observe throughout the universe. They show up as the precise, stable energy states of particles.
Like those electron shells around an atom you mentioned.
Exactly, those precise energy levels. They also dictate orbital shells in larger systems, think planets around stars or moons around planets. They even define specific field modes and contribute, the theory argues, to the very structuring of space-time itself.
Wow, so it's a pervasive generative rule for how the universe, in all its complexity, organizes and self-structures.
Yeah.
It's almost as if the universe is following an elaborate pre-existing musical score as it builds itself.
That's a very apt way to think about it. And the motivation for this axiom becomes incredibly compelling when you just look around, well, scientifically speaking. Look at the observed discrete structures across all scales.
Right, like why do electrons occupy discrete shells? Why not just anywhere?
Exactly. Why not a continuous range of energies? Or why do atoms form molecules with specific bond angles in these precise resonance patterns? Why not just random clumps?
Or planetary orbits. Kepler noticed those harmonic ratios centuries ago.
He did. And why are they spaced the way they are, often in these striking harmonic ratios?
Yeah.
And then zoom out further. Why do galaxies arrange themselves into vast filamentary lattices across these immense cosmic voids? Why aren't they just scattered randomly?
So CHRP offers one answer for all of that.
It offers a truly universal mechanism. It posits that coherence resolves into harmonics, just like that vibrating string resolves into predictable, stable overtones. It's aiming to be a singular, elegant principle explaining all these widespread, seemingly disparate phenomena.
Okay, so this paper makes a truly radical claim then. It's basically saying the music of the spheres isn't just poetry, it's the universe's blueprint.
That's the core assertion. It's not meant metaphorically. The claim is that it's ontological.
Ontological, meaning these musical relationships are the generative laws of existence.
Correct. This isn't just a nice thought. It's presented as a coherence-based description of how resonance actually structures space, time, energy, and matter. These harmonic relations aren't simply useful tools for describing what we observe. The theory posits they are the fundamental rules by which reality itself unfolds.
That really does turn our usual understanding on its head. Usually we think of the laws first, and the structures emerge. This sounds like the harmonic structures are the law.
In a very deep sense, yes.
Yeah.
The theory proposes that concepts we borrow from music, like intervals, the octave, the perfect fifth, even something dissonant like the tritone, these aren't just human constructs applied after the fact. They're seen as fundamental coherence transitions. They're lawful expressions of how coherence reduces and transforms itself.
Okay, wow. What about other musical concepts?
Similarly, things like the nodes and antinodes you see in standing waves.
The points that stand still and the points that vibrate the most?
Exactly. And the precise resonance shells and nodal geometries that define quantum orbitals or maybe even planetary spacing. The spectral layering we find from the subatomic level all the way up to the cosmological scale.
Layering, like different frequency ranges.
Kind of, yes. And what the theory calls coherence eigenmodes. Think of these as the universe's natural permitted notes or vibrational patterns that emerge, like harmonic overtones of a fundamental field.
So eigenmodes are like the allowed states.
Precisely. The stable states. These aren't just convenient ways to describe reality, the theory says. They are fundamental laws governing how reality unfolds. Each mode is a permitted, stable resonance state of a reducing coherence field. It's a very deep, direct connection between what we perceive as musicality and the very fabric of existence.
To really drive that home, let's take the electron cloud, that fuzzy area around an atom where electrons live.
Okay.
When you think of it, don't just imagine a blurry probability distribution like where an electron might be just bouncing around randomly.
Right, the standard quantum picture.
This theory suggests it's actually a precise coherence resonance map. Each shell within that cloud, each distinct energy level is a stable, permitted, harmonic, standing wave state within the atom's potential coherence field.
So the fuzziness is actually highly structured resonance.
That seems to be the idea, and it's not just a visualization tool. It offers a deeper explanation for why energy levels are quantized, why electron clouds have those specific shape, the spheres, the dumbbells, the cloverleaf patterns.
The SPDF orbitals.
Exactly. And even how atoms bond to form molecules. It suggests the geometry of bonding is also harmonically determined. It's a completely different and much more ordered way of seeing the quantum world, grounding it in these fundamental harmonic principles.
And this truly is the core insight, the central message of the theory. The reduction of coherence into harmonic resonance is presented as the universal mechanism by which structured phenomena emerge.
From the smallest to the largest.
From atoms and molecules to planets and galaxies, yes. These musical relationships, expressed as harmonic ratios and coherence eigenmodes, they're not incidental side effects. They are foundational to reality's architecture.
So coherence reduces not randomly, but through structured harmonic emergence.
Exactly. And this emergence defines the architecture of atomic, molecular, and cosmological systems through what it calls harmonic quantization. It's aiming for a singular, elegant principle to unify physics across all scales. It suggests the universe is fundamentally a coherent, structured, harmonic manifold.
Wow. Okay, so if there's one core insight from this first part, it's that the universe isn't just collapsing randomly. It's composing itself through these precise harmonic steps.
That's the essence of it.
Okay, if the universe is this grand symphony, this coherent, structured, harmonic manifold, then what are the actual instruments playing? And what are the specific notes? How do we classify all the players, the particles, the fields within this cosmic composition?
Right. That's where the theory introduces something called the Coherence Harmonic Algebra, or CHA.
CHA.
It aims to provide a formal language, like a mathematical framework, to describe precisely how fundamental particles emerge from and play specific harmonic roles within this structure.
So it's like the sheet music for the universe, defining the rules for the players.
That's a good analogy, yeah. It gives us a way to classify everything based on its harmonic role, and it gets highly specific in its classifications. First, it introduces what it calls chordal bosons.
Chordal bosons, okay. Chordal, like musical chords.
Exactly. Bosons, as you know, are typically force carriers in the standard model. Here, they're interpreted as coherence carriers. They transmit or mediate forces and information, and they're seen as being formed through constructive harmonic overlap.
Constructive overlap, like waves adding up.
Precisely, like individual musical notes combining constructively to form a richer new chord. So, for instance, the photon, the particle of light, it's seen as the most basic monadic coherence pulse, a pure fundamental unit of coherence transmission.
Okay, the simplest note. What about others?
Well, then you have the W and Z bosons. They're crucial for the weak nuclear force, right? Responsible for radioactive decay.
Right.
In CHA, these are interpreted as tritone structures.
A tritone, that's a dissonant interval in music, isn't it? The devil's interval.
It is. And interestingly, in this context, they are specifically described as chirality-inducing.
Chirality. Handedness, like left-handed or right-handed.
Exactly. They influence the handedness or spatial orientation of how interactions occur, which is actually a known key feature of the weak force. So the dissonance maps to this symmetry-breaking aspect.
Fascinating. What about the strong force? Gluons.
Gluons, which bind quarks together inside protons and neutrons, are seen as harmonic bridges between color chords. They facilitate the strong nuclear force that holds nuclei together. So they're like the harmonic connections enabling that strong bond.
Color chords relating to quark color charge.
Presumably, yes, connecting those harmonic aspects. And finally, the theory tackles gravity, the hypothetical graviton, the proposed carrier particle for gravity.
Still theoretical, but...
Right. It's conceptualized here as a coherent superharmonic resonance, a quadratic amplitude field mode that structures space-time itself, suggesting gravity is a very deep, perhaps higher-order harmonic manifestation.
A superharmonic.
Yeah.
Like a fundamental tone for space-time.
Something like that. A resonance that defines the background geometry.
Okay, so if bosons are the chords, the carriers, formed by constructive overlap, what about the fermions, the particles that make up matter, like electrons and quarks?
They're treated very differently. The theory describes them as nodal fermions.
Nodal, like the nodes on a vibrating string, the stable points.
Precisely that. They're interpreted as coherence stabilizing nodes. They emerge through a kind of anti-symmetric coherence torsion.
Coherence torsion. Like a twist.
Kind of like a stable twist or not in the coherence field. If bosons are the flowing melody or the chords, fermions are the precise stable points, the nodes, in this vibrating cosmic string that remain relatively fixed in defined structure.
Okay, give me an example. An electron.
The electron is described as a fundamental fermionic node, a coherence torsion loop, a stable, self-contained twist in the coherence field.
A loop. Interesting. And quarks. They're more complex.
Quarks, with their fractional electric charges, right? They're seen as fractional harmonic modes, showing very specific 13 and 23 amplitude phase distortions within the field.
So the fractions come from partial harmonics.
That seems to be the interpretation, yes. Specific resonance distortions. And what about neutrinos? Tiny mass, very elusive.
Almost ghost-like.
Yeah. They're considered minimal energy resonance states, almost like near-null harmonic edge states within the coherence field.
Edge states.
Yeah.
Like right on the boundary of detection or existence.
Something like that, implying they exist at the very boundaries or limits of a coherence reduction process, barely perturbing the field.
And is there a bigger picture for classifying all particles this way?
The theory does briefly outline a broader harmonic typing schema. It's meant to be a systematic classification of all particles and field entities based on their specific harmonic role, whether they act as fundamental pulses, complex tritones, stable torsional loops, or these subtle edge resonators.
So it aims to provide a comprehensive way to understand the whole particle zoo through this universal harmonic lens.
That's the goal, yes. Suggesting a deep underlying order to matter itself based on resonance roles.
Okay, that's fascinating. So if we have these distinct harmonic players, the bosons carrying pulses, the fermions forming stable matter, how do they actually interact? Does the CHA propose new forces, or does it just reinterpret existing ones harmonically? Must define specific rules, operators, right?
Exactly. It needs rules for interaction. The theory details 3 core operators that govern these harmonic interactions.
Okay, what's the first one?
The first is the harmonic overlap operator. It's symbolized by mathcal plus plus.
H plus. Got it.
This operator describes how bosonic fields constructively combine or overlap, like we discussed before, to create new, more complex, coherent states.
Like notes blending into a chord.
Precisely. It models bosonic addition and field resonance alignment. It explains how force-carrying particles can merge or interact to produce larger field effects. It's all about building complexity through resonance and constructive interference.
Okay, constructive overlap for bosons. What about fermions? They're different, right? They can't occupy the same state.
Exactly. And that's handled by the second operator, the nodal exclusion operator, symbolized by mapqual times.
And cross. Okay.
This one is absolutely crucial for understanding fermions and the stability of matter. It represents their inherent antisymmetric nature. When applied, this operator ensures that the overlap between 2 distinct fermionic nodal states is always null zero.
So basically they exclude each other.
In simple terms, yes. It's essentially a polycoherence exclusion principle derived from this harmonic framework. It ensures that no 2 fermions can occupy the exact same nodal coherent state at the same time.
Which is why electrons stack up in shells in an atom instead of all falling into the lowest energy level.
Precisely. It's what gives matter its distinct form, its volume, its structure. It prevents collapse.
Okay, so we have overlap for bosons, exclusion for fermions. What's the third operator?
The third one is kind of the master operator, the resonance cascade operator, symbolized by mathcal down arrow.
The cascade sounds like the main process.
It really is the grand orchestrator of the whole emergence process. It describes the overall mechanism of coherence reduction itself. It models how the fundamental, undifferentiated coherence field transforms or cascades down into all those discrete bosonic, and fermionic harmonic modes we've been discussing across different harmonic levels or shells, lambda.
Like a cosmic waterfall, coherence flows down and breaks into specific, allowed resonance states.
That's a very good visual, a cascade into structure. This operator essentially describes the mechanism of emergence itself, how potential becomes actual, how the unified field gives rise to the diverse particles and forces we observe.
So this theory tries to pull all of this together. The initial coherence, the structured reduction, the emergence of specific particles with specific interactions into one picture.
Yes, it distills it into what it calls the unified equation of harmonic emergence. We don't need to get bogged down in the symbols. Mathcal left one entry, but conceptually it represents this entire process.
Right. So what does that equation tell us, fundamentally?
Fundamentally, it symbolizes that the initial coherence, through the action of the resonance cascade operator, Mathieu-Caldano, gives rise to an infinite series of these bosonic and fermionic harmonic shell spaces, lambdan. Each shell space is like a discrete harmonic coherence threshold, a specific octave or key of reality.
And the stability of things, like atoms or galaxies.
That's the crucial part. The stability of any physical structure, according to this equation, depends critically on these precise harmonic relationships. How coherence fields constructively overlap, Mathcal plus, how they compensate for torsional forces that define fermions, and how nodal exclusion times plays out to maintain the distinct, stable forms of matter.
So it all has to balance out harmonically.
Exactly. This is what the paper calls the coherence harmonic quantization law. It's a profound statement about the deep underlying order of the universe rooted entirely in these resonant principles. Stability emerges from harmonic balance.
Okay, a coherence harmonic quantization law. That's a big idea.
Right.
But how does this grand harmonic principle actually, play out across the incredible range of scales we see, from the tiniest quantum fuzz to the vastness of galaxy clusters?
Right. How does it bridge those enormous gaps? The paper describes this through what it calls resonance shell cascades.
Resonance shell cascades, like nested layers.
Exactly. It's the idea of a stepwise emergence of layered harmonic zones. You see it in the tiny, precise atomic orbitals within atoms, then maybe in the stable planetary shells within star systems, and even, it argues, in the large-scale clustering of galaxies across the cosmos.
So it's like the universe is creating these nested, self-similar musical structures, echoing the same patterns at different octaves or scales.
That's the picture it paints, yes. And to illustrate this, the paper provides a really remarkable comparative plot. It terms it coherence eigenmode spectra across scales.
Okay, what did that show?
It visually illustrates how these coherence harmonics manifest differently, yet consistently, across these vast distances. For instance, at the atomic scale, the harmonics exhibit an inversely proportional relationship.
Which leads
directly to that standing wave quantization we talked about, the discrete energy levels and specific shapes of electron orbitals, SPDF. They are essentially distinct harmonic resonance patterns allowed by that inverse relationship.
Okay, makes sense for atoms. What about molecules?
As we move up to the molecular scale, the plot shows sinusoidal patterns emerging. These patterns are crucial for defining torsional and angular bonding harmonics.
Meaning the shapes of molecules.
Exactly. They dictate the precise geometry bond angles, bond lengths of molecules like water, methane, or even incredibly complex proteins. It's how the music of atomic coherence forms the specific chords and structures of chemistry.
Wow. Okay, and then the really big scales. Cosmic.
At the grand cosmic scale, the emergence pattern shifts again, this time to a logarithmic relationship. This indicates resonant spatial scaling.
And what does that define?
This is what the theory suggests. Helps define the large-scale distribution of galaxies, why they form filaments and walls surrounding voids, and the very structure of the cosmic web.
So the same principle, different mathematical expression at different scales.
Precisely. This visual representation shows how these underlying coherence fields taper or modulate, leading to distinct yet fundamentally harmonically related resonance behaviors across vastly different domains.
It's incredible how it attempts to unify those concepts. And you mentioned thresholds, where the nature of these harmonic expressions changes.
Yes, the theory posits specific thresholds defined by these discrete jumps in coherence, almost like shifting to different octaves or keys in this cosmic song.
Are there specific examples?
It suggests the threshold around N5, which is seen as marking the transition from purely atomic shell resonance to the kind of coherence needed for stable molecular bonding.
Okay.
Then, a much larger leap around N12 is proposed to mark the shift from the molecular domain to the vast cosmic harmonic structuring, the scale of galaxies and beyond.
So these different realms of physics, atomic, chemical, cosmological, are seen as distinct harmonic regimes.
Exactly. Distinct regions of physical reality, but still governed by the same overarching harmonic principle, just expressed differently as coherence decays or reduces across these thresholds. It's like the universe hits a certain note and then shifts its entire harmonic structure for the next scale up.
Okay, to describe this architecture more formally, the theory introduces a new mathematical tool. Right, something about curvature.
Yes, a very powerful one. The coherence curvature tensor, symbolized as mathlity. Now, the full math involves advanced differential geometry, so we won't get lost in the weeds.
Please don't.
Right. But conceptually, this tensor is designed to weave together two things: the density gradients of coherence, how concentrated the coherence field is locally, and the very curvature of spacetime itself.
So it links the harmony to the geometry.
That's the ambition. Its purpose is multifaceted. It encodes how local coherence density changes. It describes how the field manifold itself, the fabric of reality gets curved due to coherence reduction, and it models the intricate interaction between harmonic phase coherence and spatial torsion.
Torsion again, like with the fermions.
Yes, that twisting aspect. In essence, it's a mathematical way to describe how the fundamental reduction of coherence literally bends and shapes reality. It aims to integrate the music, the quantum harmonic content, directly into the geometric framework of spacetime.
Okay, can you simplify that interpretation for us? How does it behave differently at small versus large scales?
Think of it this way. At the tiny scale of atoms and molecules, the harmonic part of that tensor, the resonance patterning, is what primarily dominates.
Okay.
This describes how those underlying harmonic waves create electron shells and define precise molecular bond angles, the quantum and chemical structure.
Right.
But when you scale way up to the cosmic level stars, galaxies, the coherence gradient terms, and other curvature terms within the tensor start to take over. They become dominant.
And what do they describe?
At this vast scale, the tensor primarily describes the structure and gravitation of massive objects. It essentially shows how the reduction of coherence transforms into the very geometry of curved space that Einstein described with general relativity.
So it's a continuum. The same underlying principle manifests as quantum harmonics at one end and gravity geometry at the other.
That's the claim. A continuum where the phenomena look different depending on the scale and the dominant terms in the tensor. And this leads to a really remarkable concept they call coherence curvature bubbles.
Bubbles.
Yeah, localized regions where reduced coherence manifests as a distinct curvature zone, essentially. A stable bubble of structured harmonic tension. Each of these zones can be thought of as a quantized shell in the overall curvature spectrum, with precise, measurable coherence tensor magnitudes associated with it.
Can you give examples of these bubbles?
Sure. An atomic core would represent extremely high coherence, TIA 0.95 according to their scale, leading to very minimal curvature. It's almost pure coherence field.
Okay.
As coherence reduces slightly, you get a molecular shell, TIA 0.75, where coherence is still high, but stable torsional structuring defining molecular shapes becomes dominant.
Makes sense. Further out.
An orbital zone, TIA 0.50, like where planets orbit a star. Here, there's an intermediate balance between resonance effects and gravitational potential, defining those stable orbits.
Right.
Scale up again, and you get a stellar bubble,
Yeah.
TIA 0.30. Here, coherence is lower, and the curvature induced by the star's mass begins dominating the energy structuring, propagating its gravitational field.
And finally, galaxies.
A galactic bubble, TF 0.15, signifies relatively low coherence but very strong spatial curvature, shaping the grand structure of the entire galaxy. Each zone is like a distinct harmonic bubble of influence with a characteristic coherence value.
It's quite astounding how this bubble concept highlights the transformation. Coherence starts as intensive energy fields inside atoms.
Right.
One becomes structured bonds holding molecules together, and eventually manifests as the curved space dictating cosmic geometry. It really paints a picture of a seamless continuum of emergence.
All driven by the same underlying harmonic principles, yes, just expressed differently at different scales, corresponding to different levels of coherence reduction. It aims to explain the entire hierarchy of structures we see through this singular harmonic lens.
And does the theory go further? What about interactions between these bubbles, like binary stars or merging galaxies?
It does. It explores binary coherence systems. When two of these coherence curvature bubbles interact like two stars orbiting each other or entire galaxies colliding,
Yeah.
their individual coherence fields don't just passively add up, they overlap and actively interfere, generating complex harmonic interference zones.
So it's not just gravity pulling them, their coherence fields are interacting musically, so to speak.
That's the idea. It creates dynamic curvature wells and new, intricate structures based on that harmonic interference. It offers a potentially richer way to model complex gravitational and field interactions, suggesting even grand cosmic dances are governed by these underlying resonance principles.
Wow. And this brings us, I guess, to the biggest scale of all, the whole universe.
Pretty much. The concept of the galactic scale coherence resonance lattice.
Okay, paint that picture for us.
Imagine the universe not just as isolated objects floating in space, but as a vast interconnected network, a cosmic web.
We see that structure in observations.
Exactly. In this theory, each galaxy is effectively a coherence core, radiating its own curvature field, its own bubble, into the cosmic tapestry. It's like a gigantic, intricate, invisible web woven from these subtle harmonic threads connecting everything.
An interconnected network of coherence cores.
Precisely, and these radiating fields interact across unimaginable distances. They create resonant interference zones between the galactic nodes.
And those zones are...
Those zones are not empty space. They actively form the filamentary pathways and the immense cosmic voids we observe in the universe's large-scale structure. The filaments are zones of constructive interference, perhaps, and the voids are zones of destructive interference or lower coherence.
So the cosmic web is the harmonic structure made visible.
That's the implication. It's as if the entire universe is a gigantic, harmonically structured manifold, with galaxies forming the vibrant, luminous nodes of this cosmic web, all connected by the subtle yet powerful symphony of coherence. This framework attempts to directly explain observed cosmological structures through a completely new and deeply resonant lens.
Potentially offering insights into why matter clumps the way it does.
Exactly, and maybe even shedding light on mysteries like dark matter or dark energy by framing them within this coherent structure. It's a universe where geometry isn't just a passive stage, but is actively, continuously sung into being.
Okay, so we've journeyed through the core ideas. The coherence field, the CHRP, the harmonic algebra, the curvature tensor, these nested bubbles and lattices. But let's pull back. What does this all mean for our fundamental understanding of reality? This theory, centered on the coherence harmonic reduction principle, seems to lay out some truly profound consequences. Beyond the fascinating physics, why should you, listening now, care about all these harmonic fields and curvature bubbles?
That's the key question, isn't it? The paper details 4 key sweeping consequences of embracing CHRP, and they really are quite mind-bending. They challenge some core assumptions.
Okay, what's the first big one?
First, it suggests that quantization is harmonic, not arbitrary.
Meaning the discrete nature of things. Energy levels, particle properties.
Exactly. The fact that things exist in discrete packets isn't just some weird quirk of quantum mechanics or an unexplained rule. Instead, these discrete energy levels, specific particle masses, distinct forms, they're argued to be direct results of the permitted harmonic states that emerge naturally from coherence reduction.
So the universe isn't just randomly broken into pieces. It's inherently musically structured, like only certain notes on a scale are allowed.
That's the core idea. Each quantized state is a stable resonance, an allowed harmonic.
Okay, that's big. What's number 2?
Second, it asserts that harmonic structure underlies all scales. This is aiming for that grand unification.
No sharp break between quantum and cosmic.
Precisely. No arbitrary divide between the rules of the quantum world and the rules governing stars and galaxies. Instead, the theory proposes a seamless progression of these nested coherence zones, all governed by the same underlying harmonic principle, just scaled and expressed differently based on the coherence level.
So a common language, consistent rules, from particles to superclusters.
That's the goal, bridging that long-standing divide in physics with a single harmonic foundation.
Okay, what's the third implication? You hinted it was mind-bending.
This one really is. Third, it implies that geometry itself is musical.
Geometry is musical. Wait, what?
Yeah. The very curvature of space-time, which we normally link to gravity and mass via Einstein.
Right. And the mass of particles themselves and how fundamental fields interact, the theory, suggest all of these emerged directly from the interference patterns created by these underlying coherence harmonics.
So reality isn't just happening on a geometric stage. The geometry is the harmonic interference pattern.
That's the radical proposal. Imagine reality not as a static backdrop, but as this dynamic, vibrating field where interference patterns literally create the shapes, the structures, the forces, the dynamics of the universe. Like watching Chladni patterns form in sand on a vibrating plate, but for space-time itself.
Wow, so the shapes and motions are fundamentally resonant relationships. The universe's geometry is literally sung into being.
That's the profound implication. It connects the tangible world directly to these intangible harmonic principles.
Okay, my mind is slightly bent. What's the fourth implication?
The fourth one is also very intriguing, especially for future possibilities. It offers a new lens through which to understand concepts like zero-point energy, ZPE.
That background energy field that supposedly permeates all of space.
Exactly. Often seen as a theoretical curiosity or something impossibly hard to tap into. This theory suggests that these ZPE-like fields are, in fact, manifestations of the fundamental coherence field, the energetic fabric of reality itself before reduction.
So ZPE is the coherence field.
Or at least deeply related to it. And here's the kicker. If we could deeply understand these harmonics, how they cascade, how they resonate, it hints at the astonishing possibility that we might eventually be able to extract energy from this field
Ah,
through precise phase resonance, like tuning into a specific frequency to draw energy out. It opens up entirely new, maybe revolutionary, frontiers for understanding fundamental energy sources, potentially moving way beyond our current paradigms.
that is a profound set of implications. Quantization is harmonic, structure is universal, geometry is musical, and maybe even limitless energy.
Potential energy, yes, tied to this fundamental coherence. It's a very different view of the cosmos.
And you mentioned earlier, even though the paper only touches on it briefly, that there could be big implications for cosmology, like dark matter, dark energy.
Absolutely. If the large-scale structure of the universe, that cosmic web, the filaments and voids, truly emerges from these coherence harmonics, as the galactic resonance lattice idea suggests,
Yeah.
then it could offer a completely new way to model the universe's grand architecture. Perhaps what we currently attribute to mysterious, unseen dark components is actually an effect of the underlying coherence field dynamics and its harmonic structuring.
So it might provide a more complete picture, explaining that missing mass or energy, not as exotic stuff, but as part of this fundamental harmonic framework.
It's a possibility raised by the theory, yes.
Yeah.
It could potentially offer a more unified and elegant explanation for the unseen scaffolding of the cosmos, framing it all within coherence and resonance.
This truly is an ambitious framework, then. It's really trying to integrate so many seemingly disparate pieces of physics, quantum mechanics, chemistry, gravity, cosmology.
From the electron's behavior to galactic dynamics, yes. Trying to weave it all into one elegant harmonic whole.
It's a vision where the universe isn't just, a collection of particles randomly bumping into each other according to statistical rules,
Right.
but a vast unfolding symphony, a unified physics of structure and form, as you said, integrating resonance quantization, coherence decay, and curvature emergence.
It definitely challenges us to look beyond our standard models and consider a universe that might be, at its very core, music. #outro.
Wow. Okay, what we've unpacked today is, well, it's a truly radical vision, isn't it?
Yeah.
That the universe isn't just a jumble of random interactions, not just billiard balls bouncing around in empty space.
Far from it.
But instead, it's like a finely tuned instrument. Every particle, every atom, every star, every galaxy emerges lawfully, purposefully almost, from these fundamental harmonic field principles. It's presented as a coherent, structured, harmonic manifold.
A universe that is, in its very essence, a living, breathing song, constantly composing itself.
Yeah.
That's the picture.
It really is, and it leaves you wondering.
It does. This deep dive really invites us to consider. If reality is fundamentally harmonic, if everything from the smallest quark to the largest cosmic void is a note or a chord in this universal composition, what other notes and chords might be waiting out there for us to discover?
Or maybe even notes within us.
That's an even deeper question. Could our own consciousness, our very thoughts and perceptions, perhaps be a form of coherence resonance within this universal symphony? Are we active participants in the ongoing composition, not just listening, but responding to, maybe even contributing to, the cosmic music?
That is a provocative thought to end on. A truly mind-expanding possibility.
It certainly gives you something to mull over.
Absolutely. Well, we hope this deep dive has given you some incredible new insights, maybe challenged some assumptions, and perhaps even sparked a fresh appreciation for the underlying order and, well, the profound musicality of the cosmos.
Keep asking questions.
Keep learning, keep exploring, and maybe, just maybe, if you listen closely enough, you'll start hearing the universe's song a little more clearly.